Hope my screen is visible to all of you.
Yes, sir.
Okay. Okay, good evening, everyone. My name is Yash Prajapati. Today's lecture is about motor, and we will see what types of motors are there and how they works, and we will also discuss what is motor designing. Mostly, we will discuss. We will focus on motor designing, and we will cover all the topics. What is BLDC motor and classifications, advantages, and what is hub motor, advantages of hub motor, and designing of hub motor using Solidworks. So what is BLDC motor? A BLDC motor, brushless DC motor, is a type of electric motor that uses magnets to generate motion, unlike traditional brushed DC motor. BLDC motors do not use brushes for commutation. Instead, they rely on electronic commutation for switching the direction of current flow in the motor windings. And here's some key features and components of a BLDC motor, like permanent magnets, stator, electronic commutation. So BLDC motor typically have permanent magnets on the rotor, the rotating part of the motor. These magnets can be either on the rotor itself or embedded in the rotor. The rotor is the stationary part of the motor and contains windings, coils of wire. The windings are energized with electric current, creating a magnetic field. In BLDC motor, the commutation process, switching the directions of current flow in the windings, is handled electronically by an external controller. This is in contrast to brushed DC motor, which use mechanical brushed for commutation. BLDC motor can be operated with or without sensors. Sensorless operation relies on algorithms and feedback from the motor to determine the rotor positions. While censored operation uses additional sensors, Hall effect sensor, to provide feedback on the rotor position. BLDC motor are known for their efficiency and reliability. They offer better performance, longer lifespan, and lower maintenance requirements compared to brushed DC motors. BLDC motors find application in a wide range of devices and systems, including electric vehicle, computer, cooling fans, household appliances, robotics, industrial automation, and more. Their efficiency and precise control make them suitable for various high performance applications. Brushless DC motor are also the precise speed control and are often used in applications where maintaining a specific speed or achieving variable speeds is important. Overall, BLDC motors are popular in many industries due to their efficiency, reliability, and precise control capability. They have become increasingly common in various electromechanical systems, contributing to the development of modern technologies. There are several types of BLDC motors, each designed for specific applications, like outrunner, internal rotor motor, external rotor motor. So, an outrunner BLDC motor, the rotor part that spins is on the outside. Surrounding the stator, the stationary part, the design often provides a higher torque at lower speeds, making outrunner motors suitable for applications such as electric scooters, model airplanes, and 10 types of electric vehicles. Next, in-runner motor. In an in-runner BLDC motor, the rotor is located These motors are used in various applications, including robotics, small appliances, and power tools. An external rotor BLDC motor have the rotor located on the outside of the rotor. This design allows for a large diameter, which can contribute to higher torque and speed. External rotor motors are commonly used in application where space is not a critical constant. Constraints such as certain industrial applications and fans. Brushless DC motor can be classified based on their control method as censored and sensorless. Censored motors are additional sensors such as Hall effect sensor to provide feedback on the rotor position. Sensorless motor rely on algorithm and back electromotive force EMF to determine the rotor position without the need for additional sensors. Sensorless motors are often used in application where a simpler design is desired. BLDC motor can also be categorized based on the shape of the back EMF waveform. Sinusoidal motors produce a sinusoidal back EMF, providing smoother operation and better efficiency. Especially at low speeds, trapezoidal motors produce a trapezoidal back EMF waveform and are commonly used in application where simplicity and cost effectiveness are crucial. So this is the DC motor and AC motor. There are three types of DC motor: brush DC motors, brushless DC motor, stepper motor, and AC motors, induction motor, synchronous motor. And next, why do BLDC motors turn? Brushless DC motor do not use brushes with brushed motors. The brushes deliver current through the commutator into the coils on the rotor. So how does a brushless motor pass current to the rotor coils? It doesn't, because so how does a brushless motor pass current to the rotor coils? The coils are not located on the rotor. Instead, the rotor is a permanent magnet. The coils do not rotate, but are instead fixed in place on the stator. Because the coil do not move, there is no need for brushes and a commutator. With the brushed motor, rotation is achieved by controlling the magnetic fields generated by the coils on the rotor, while the magnetic field generated by the stationary magnet remains fixed. To change the rotation speed and change the voltage for the coils with a BLDC motor, it is the permanent magnet that rotation is achieved by changing the direction of the magnetic fields generated by the surrounding stationary coils. To control the rotation, you adjust the magnitude and direction of the current into these coils. What are the advantages of BLDC motors? BLDC motor with three coils on the stator will have 6 electrical wires to each coil extending from these. In most implementations, three of these wires will be connected internally, with the 3 remaining wires extending from the rotor body. In contrast to the 2 wires extending from the brushed motor described earlier, while like wiring in the BLDC motor case is more complicated and simply connected the power cells, positive and negative terminals. We will look more closely at how these motors work in the and one big advantage is efficiency, as these motors can control continuously at maximum rotational force torque. Brushed motor, in contrast, reach maximum torque at only certain points in the station for a brushed motor to deliver the same torque. As a brushless model, it would need to use larger magnets. This is why even small BLDC motors can deliver considerable power. The second big advantage related to the first is controllability. BLDC motor controlled using feedback mechanism to deliver precisely the desired torque and rotation speed. Precision control in turn reduces energy consumption and heat generation. And in case where motors are battery powered, lengthen the battery life. BLDC motors also offer high durability and low electric noise generation. With brushed motor, the brushes and commutator wear down as a result of continuous moving contact, and also produce sparks where contact is made. Electrical noise in particular is the result of the strong spark that tend to at the area where the brushes pass over the caps in the commutator. This is why BLDC motors are often considered preferable in application where it is important to have electrical noise. And we have seen that BLDC motor offer a high efficiency and controllability, and that they have a long operating life. So what they're good for because of their efficiency and longevity. They are widely used in devices that run continuously. They have long been used in washing machines, air conditioner, and other consumer electronics. And more recently, they are appearing in fans, where their high efficiency has contributed to a significant reduction in power consumption. And there are also being used to drive vacuum machines. In one case, a change in the control program resulted in a large jump in rotational speed. An example of the superlative controllability offered by these motors. BLDC motors also being used to spin hard disk drives, where their durability keeps the drives operating dependably over the long term, while their power efficiency contributes to energy reduction in an area where this is becoming increasingly important. And what is the future in BLDC motor? So we can expect to see BLDC motor used in a wider range of applications in the future. For example, they will probably be widely used to drive service robots, small robots that deliver services in fields other than manufacturing. One might think that stepper motors would be more suitable in this type of applications, where pulses could be used to precisely control positioning, but BLDC motor are better suited to controlling the force. And with a stepper motor, holding the position of a structure such as robot arm would require a relatively large and continuous current with a BLDC motor. All that would be required is a current proportionate to the external force, allowing for more power efficient control. BLDC motors may also be replacing simple brushed DC motors in golf carts and mobility carts. In addition to their battery efficiency, BLDC motors can also deliver more precise control, which in turn can further extend battery life. Next. Access port is hub motor. Most electric powered vehicles, electric cars, electric bicycles, and wheelchairs use onboard onboard batteries, and a single fairly ordinary electric motor to power two or four wheels. But some of the latest electric cars and electric bicycles work a different way. Instead of having one motor power all the wheels using gears or chains, they build a motor directly into the hub of each wheel. So the motors and wheels are one and the same thing. That's what you mean by a hub motor. So PLDC motor are more efficient than brush motors because they don't suffer from the energy losses associated with friction in the brush and commutator. Since there are no brushes to wear out, maintenance is reduced compared to brushed motors. Hub motors can be compact and lightweight, contributing to the overall simplicity and aesthetic of the electric vehicle. And some BLDC hub motors support regenerative braking system, where energy generated during braking is fed back into the battery, improving overall energy efficiency. BLDC motors tend to operate more quickly than brushed motors. BLDC hub motors are commonly used in electric bicycles, electric scooters, and electric skateboards. Their design makes them well suited for application where a simple, compact, and efficient motor is desired. And the basic idea is just the same. In an ordinary motor, you have a hollow outer ring shaped permanent magnet that stays sometimes called a stator, and an inner metallic core that rotates inside it called the rotor. The spinning rotor has an axle running through the middle that you use to drive a machine. But what if you hold the axle firmly so it can't rotate and switch on the motor? Then the rotor and the stator have no choice but to swap roles. The normally static rotor stay still while the stator spins around it. With a with an electric toothbrush, instead of holding the plastic case of your toothbrush, which broadly speaking connected to the static part of an electric motor, try holding only the bristles and then turn on the power. It's quite tricky to do because the brush moves so fast. But if you do it right, you will find the handle slowly rock back and forth. This is essentially what happens in a hub motor. And you connect the central normally rotating axle to the static frame of a bicycle on the or the chassis of a car. When you switch on the power, the outer part of the motor rotates, becoming a wheel that powers the vehicle forward. Ordinary electric motors use a mechanical device called a commutator and two contacts called carbon brushes to reverse the electric current periodically and ensure the axle keeps turning in the same direction. Hub motors are typically brushless motors, sometimes called brushless direct current motor or BLDC, which replace the commutator and brushes with half a dozen or more separate coils and an electric circuit. This circuit switches the power on and off in the coils, in turn creating forces in each one that make the motor spin since the brushes press against the axle of a normal motor. They introduce friction, slow it down, make a certain amount of noise, and waste energy. That's why brushless motors are often more efficient, especially at low speeds. Hello. Okay, getting rid of the brushes also saves having to replace them every so often, which friction wear them down. and the inner coil rotate. It's called the rotor, and the outer magnet to stay static. That's called the stator. But but in this motor, the roles are reversed. The inner part with the coil says static, and the gray magnet spins and around it. Now look inside, and you can see exactly how it works. The electronic circuits sends power round the 9 copper coils. It in turn making the gray outer case, which is a on the copper coils and the circuit board. And how does the circuit know which of the 9 coils to switch on and off? And then you can't really the Hall effect sensor position between some of coils as a permanent magnets on the outer rotor. Sweep past them. The Hall effect sensor figure out where the north and south magnetic poles of the rotor, and which coils to activate to make it up spinning. The trouble with this is that it means the rotor does need on electronic circuit to operate it, which is something you don't need for a ordinary DC motor. So what are the advantages of a hub motor? It depends whether you are taking about an electric bicycle or an electric car. Adding a hub motor and batteries to a bicycle is a mixture of pro and con. You increase the bicycle's weight quite considerably, but it return you get a pleasant and effortless ride whenever you don't feel like pedaling. Electric cars are concerned, the benefits are more obvious. The weight of the metal in a typical car, including the engine, gearbox, and chassis, is perhaps 10 times the weight of an equipment, which is one reason why cars are so very inefficient. So, if the heavy engine and gearbox for hub motors and batteries, and you have a lighter car that uses energy far more efficiently, getting rid of the engine compartment also frees up a huge amount of space, and passengers and their luggage, you can just show the battery behind the back seat. And the vehicle powered by hub motors are a whole lot mechanically less complex than normal ones. Suppose you want to reverse instead of using elaborate arrangements of gears. All you have to do is reverse the electric current. The motor spins backward and back. You go what about 4 wheels drive? That's quite an expensive option on a lot of vehicles. You need more gears and complicated drive shafts, but it's very easy to sort out with a hub motor. If you have a hub motor in each of a car's 4 wheels, you get 4-wheel drive automatically. It's easy enough to make the 4 motors turn at different speed to help the cornering and steering or torque to move you through muddy or uneven terrain. Next, what are the problems of a hub motor? Like handling. Hub motor are bigger, bulkier, and heavier than ordinary wheels, and change the handling of an electric car or bike. They increase the unsprung mass, the mass not supported by the suspension, theoretically giving more shock and vibration, poorer handling, and bumpier ride. That's the common wisdom. Anyway, in practice, engineers have found that vehicles with motors simply need to have their suspension tweaked and compensate for the extra unsprung mass, and this can even lead to an overall improvement handling. So next is safety. The sudden failure of a single hub motor could cause a vehicle to slew to one side, which is why practical hub motors are sometimes made up of several typical 4 independent sub motors. each producing a fraction, a quarter of the overall torque. That's a much safer design, but it does add to cost and complexity. Even so, the 2 or 4 motors in hub motors, 4 in 1 or more of the motors on the opposite sides. Guys, if you have any question, then you can ask. Unlike a conventional engine or an electric motor high off the road and costly sheltered inside the engine compartment, hub motors have to survive in a much more extreme environment. As we have just noted, they are unsprung, so they are subjected to huge amounts of vibrations, and they also have to survive high speed impacts from rocks and stones down by the roads. They have to cope with huge extremes of temperature, freezing cold from the outside, air boiling hot from sudden braking, and getting completely submerged in water or snow. Can hub motors last as long as traditional engines or electric cars with a single central motor? Isolated hub motors are something of a futuristic ideal for the time being. Hub motors more likely to the retrofitted to existing cars, so they have to work with existing friction brake suspension system and so on. That can mean design compromises that undermine some of the advantage of using hub motors in the first place. And how to design an electric motor with high efficiency, and which electric motor design software is best for this. The procedure described here can be applied to both AC motors and DC motors. AC motor include BLDC motors, which are also known as brushless motors. Axial flux motors and induction motors, such as those made by Tesla, are also designed using the method. The design steps and electromagnetic calculations for electric motors are and the first step to design an electric motor is to...
Voice is breaking.
Yes.
Actually, your voice is breaking. I think your voice was breaking a bit.
Okay. Hello.
Now it's audible.
Okay. Yes. Now you're audible. Ask.
Actually, sir, I was going to ask that are axial motor, flux motors are brushless or not?
Can you repeat again?
I want to say that are axial flux motors that are brushless, and how can we use those kind of motors, or rather, where can we use it?
Okay. Actually, axial motors are typically shorter and wider than an equivalent radial motor. Axial motors have been commonly used for low power application. Okay, especially in tightly integrated electronics, since the motor can be built directly upon a printed circuit board PCB, and can use PCB traces as the stator winding.
Sir, can I ask a question?
Yes.
Sir, is regenerative braking possible in DC motors?
What?
Is regenerative braking is possible in DC motors?
Yes, yes, of course.
Or is it only limited for BLDC motors?
What, ma'am?
Sir, regenerative braking is only limited for BLDC motors, or is it possible for DC motors also?
Only for DC motor, ma'am.
No, sir. Means is it limited for only for BLDC motors, or for DC motors I can use regenerative braking?
एक Actually, regenerative braking works by reversing electric motor that propel a vehicle. It works like a generator and feeds energy back into the hybrid or electric
Yes,
system.
sir. That
to
I
help,
know, but
yes.
I want to ask: is it possible in DC motors rather than BLDC motors?
Can you repeat again?
Is regenerative braking possible in DC motors rather than BLDC motors?
Yes, 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 yes. Is it possible? Is possible in DC motor, brushless DC motor. Am I audible? Hello.
Hello.
Yes, regenerative is possible in DC series motor since the field current cannot be made greater than the armature. Regeneration is required where DC series motor is used extensively, such as in traction, elevator, hoist, etc.
Okay, sir.
Okay. And an architecture of the electric drive system should also be created consisting of the electric motor, inverter, and if necessary, a gearbox and architecture helps to understand how the different components interact with each other, mechanically, electrically, and thermally. The architecture helps to understand the relationships and interaction of the electric motor, inverters, and gearbox. With the architecture, it can be discussed how the drive system can be optimized and where cost can be reduced. In the pre-selection, should be very carefully consider what type of electric motor is the best for a specific application. Each electric motor has its advantages and disadvantages. With the help of previously written requirements and prioritization, should be compared which type of electric motor is best suited for the specific application. It should also be considered in which number of units the electric motor is to be produced later, because the winding technology used in also derived from the number of units, and the winding technology has a great influence on the electric motor design. So select the correct starting points of the calculation is not so important. There are equations for estimating the size of the electric motor for a given power. But the easiest way is to simply look at what dimension used other manufacturer and competitors who have similar requirements. In most cases, the starting point for the electric motor design is already next, designing of hub motor using Solidworks. So next we will see how to design a motor on Solidworks software. Now let's move on the software. Next, we will design the motor. So first we will select the top plane. Then go to the sketch and select circle. First, we will make a circle. And then we will go to the smart dimension. And here we will give 100 mm. Make one more circle. $90 mm. After that, go to the features and select extruded boss base command. And here we will give 90 mm. And select next, select the surface. Create one more circle. And again go to the feature and select extruded boss base. And here we will give 5 mm. Next, select this surface. Here we will draw center line. Select rectangle. And make one rectangle here. After that, go to the circular sketch pattern. And here we will create 6 rectangles. Click OK. After that, go to the feature and select extruded boss face. Extruded up to 70 mm. Sorry, 80 mm. Click OK. Again, select this surface. Let's make a circle here. And go to the smart dimension. Select and dimension will be 40 mm. Go to the feature and extrude. Click OK. So this is the rotor part. And this is the copper plates and outer casing. Next, select this surface, click OK. And here we will draw an ellipse. So sketch and select ellipse. First, we will draw a center line. Here we will draw a center line. Now go to the circular sketch pattern. Click OK. And we will cut this section feature and go to extruded cut. And here we will give 50 mm cut. Now again select this surface. Make one more circle. Again go to the feature and select extruded. And extrude it up to 30 mm. Click OK. And next we will make permanent magnets. Select ellipse. And here we will draw one center line. Select circular sketch pattern. And here we will give we will create six ellipses. That is called permanent magnet. Now go to the feature and extrude it. and it will give a 70 mm. And now the part will be extruded. And it will give 70 mm. Click OK. And now we will provide a material. These are the copper plates, and this is the rotor part, and these are permanent magnets. And next we will select the flit. This is the complete motor design. If you have any question related to this motor designing, if you have any question, then you can ask. Okay. Anyone have any question?
Unless like if you are having any questions, you may ask now. I think no one has any questions. Kashyap, you can proceed.
Okay, thank you.
Thank you, everyone. It was a pleasure being with you today, and yeah.
Okay,
Yeah,
thanks,
thank you,
Yes,
Yash.
thanks, Yes, for hosting the
Thank you, ma'am.
webinar. Thank you. So your expertise and insights were invaluable for our learners. And thanks, learners, for attending the webinar. I hope this webinar helped you out to upskill your learning and skills. So I would like to take the opportunity to introduce our company, ISIE India Products and Services, that we offer an EV technology with small video. So have a look, please.
Do you also want to expand your knowledge of electric vehicles and want to secure a good job in the automotive industry? Let me help you to get there with our online and offline products. ISI India has been offering specific domain courses as per the industry demands with perks like pay after placement, no cost EMI, placement assurance, global wide certification by Automotive Skill Development Council ASDC and National Skill Development Corporation NSDC Government of India. We have range of courses in electric vehicle, computer-aided design and engineering, including postgraduate certification and executive PG program in EV, professional master certification program, specialization programs, fundamental programs, and internship in EV CAD and CAE. Our postgraduate certification program in EV is specially designed for the students with 120 plus online learning hours, 100 plus hours of industrial projects and internship to give exposure of various computational tools for hybrid electric vehicle applications. It is a 12 months assured placement course with pay after placement, thus encouraging the learning without financial constraints. The course is globally valid, certified from NSDC Government of India. Our executive postgraduate program in EV is specially designed for the working professional who want to upskill themselves or looking for a career change in the EV industry. With 120 plus online learning hours, 20 plus hours of industrial projects. It is a 9-month assured placement course with globally valid certification from NSDC and ASDC Government of India. Our professional master certification program in EV, CAD and CAE is specially designed for the undergraduate students to pave their career path by providing industry relevant skills with 100 plus online learning hours, 5 plus hours of industrial projects. It is a 6-month placement assistance course with globally valid certification from NSDC Government of India. Along with the courses for skilling, reskilling, and upskilling, at engineering institutes across India, we are setting up a state-of-art facility, Center of Excellence for e-mobility research and skill-based education, which is equipped with research and project-based learning-oriented experimental setups. This Center of Excellence is not only limited to educate the students, but also it will be utilized for research, innovation, and product design and development. It is a combination of 6 labs, including EV powertrain training and research lab, battery BMS training and research lab, EV charging and battery swapping lab, software modeling and simulation lab, innovation lab, and renewable energy lab. Each lab is consist of number of customized workbenches and machineries. Few of them includes EV drivetrain experimental setup and motor testing workbench, hybrid drivetrain experimental setup with data logger, EV machine cutout section workbench, two-wheeler, three-wheeler, four-wheeler training workbench, battery load capacity testing, battery BMS with CAN protocol workbench, V2G setup, on or off-grid work charging station, battery swapping, autonomous vehicle training workbench, solar power generator and software solutions, and many more. No matter from which branch you study, we commit to skill and assure you a success in your career. We have spread the joy on thousands of faces, becoming their partner along with the journey towards success. Join us and take advantage to unlock endless career opportunities.
Thanks, learners, for watching the video patiently. As mentioned, we have a proven track record and believes that our product and services will provide great value for you all. So don't miss out on this exclusive opportunity to discover the endless possibilities of electric vehicle. So any of you want to enroll in these courses, kindly send us an inquiry through a QR code displayed on your screen and take your first step towards a more sustainable and exciting future. Thank you, everyone.